I'm a neuroscientist, and I'm the co-founder of Backyard Brains. And our mission is to train the next generation of neuroscientists by taking graduate-level neuroscience research equipment and making it available for kids in middle schools and high schools. And so when we go into the classroom, one way to get them thinking about the brain, which is very complex, is to ask them a very simple question about neuroscience, and that is, what has a brain? When we ask that, students will instantly tell you that their cat or dog has a brain, and most will say that a mouse or even a small insect has a brain, but almost nobody says that a plant or a tree or a shrub has a brain. And so when you push, because this could actually help describe a little bit how the brain actually functions, so you push and say, well, what is it that makes living things have brains versus not? And often they'll come back with the classification that things that move tend to have brains. And that's absolutely correct. I mean, our nervous system evolved because it is electrical, it's fast, so we can quickly respond to stimuli in the world and move if we need to. But you can go back and push back on the students. You say, well, you say that plants don't have brains, but plants do move. Anyone who's grown a plant has noticed that the plant will move and face the sun. But they'll say, but that's a slow movement, that doesn't count. That could be a chemical process. But what about fast-moving plants? Now, in 1760, Arthur Dobbs, the royal governor of North Carolina, made a pretty fascinating discovery. In the swamps behind his house, he found a plant that would spring shut every time a bug would fall in between it. And he called this plant the fly trap. And within a decade, it made its way over to Europe, where eventually the great Charles Darwin got to study this plant, and this plant absolutely blew him away. He called it the most wonderful plant in the world. This is a plant that was an evolutionary wonder. This is a plant that moves quickly, which is rare, and it's a plant that's carnivorous, which is also rare. And it's in the same plant. But I'm here today to tell you that's not even the coolest thing about this plant. The coolest thing is that the plant can count. So in order to show that, we have to get some vocabulary out of the way. So I'm going to do what we do in the classroom with students. We're going to do an experiment on electrophysiology, which is the recording of the body's electrical signals, either coming from neurons or from muscles. And I'm put some electrodes here on my wrists, and as I hook them up, we're going to be able to see a signal on the screen here. And this signal may be familiar to you. It's called the EKG, or the electrocardiogram, and this is coming from neurons in my heart that are firing what's called action potentials. Potential meaning voltage, and action meaning it moves quickly up and down, which causes my heart to fire, which then causes the signal that you see here.